So the recording has begun. This is day 3. Day 3, week 6. So this is 3 out of 4, right? I don't understand how the week, I don't know how the week gone so. How? It just was Sunday. No, it just was Saturday night. It literally just was Saturday night. So I don't know.
Okay.
Yeah, it just fly. It just flew, like they'd say. I don't know. Anyway, so we did all of this. Area, the depth and everything. And so we passed all of this. We already finished these things. Remember, please place here or present. Send it to my WhatsApp chat again. Place here or present. Send it to my WhatsApp chat. Oh, that means we finished this paper. Oh, okay. All right, so let's begin with this one then.
We got the probability.
Yes. I did promise to go down to the probability. And just before I came to class, I was like, wow, I didn't even. This is like few moments before class. I was like, whoa, I didn't even look at that. Um,
Wow.
so what I'll do is, I'll go over this one because I did promise to go over this one. And while I'm doing this problem and while going through the class, I could see if I could find what I need to answer that probability question. If not, we'll just do it tomorrow.
We repeating this question.
Yeah, because I felt that this wasn't a good working that I gave. It was all over the place. So I want to do this over. Okay, so
Yeah, you can explain it again, please, because last time I didn't really understand.
you didn't understand? Okay. All right, so no problem.
I understand, but I need a little bit more
A little more
explain.
explanation. That's true. That's no problem. So let's do this question over. So and let's see if we can explain it better. We hope. So the idea is that we have 1 over x, and I think it's minus 1 over 2x. I need to make sure we have space. Minus 1 over 2x. One over 2x plus 1 over 3x equals to, well, it's equals to
One.
1 and 2/3, right? But we know that 1 and 2 over 3, if we saw before, is simply, if we multiply this and that, if we change it into a mixed number, it's going to be 1 times 3 is 3 plus
3 plus
5 over 3.
5.
So we change that immediately to 5 over 3. So, okay, so let me allow the process to come back in. I want to come in. All right. So again, the question is, how do we do it? Anyone remember how we got it?
We define a number. What could go into? What could go into the numbers?
Yeah. So what happens is we have 2x, and so we have 2x, 3x, and 3 and x, and so excuse me, and so we see that the LCM of 2 and 3, the lowest common multiple of 2 and 3 is 6. So that means that 2 could go into 6, 2 could go into, sorry, 3 could go into 6, and 3 could also go into 6. And so we know that we have to multiply everything by 6. We also see that most of these terms have x, and so x would also be a part of it. So that's why we use 6x, because um, the LCM of 2 and 3 is 6, and also because most of these terms have x in it. And we're trying to get rid of the x. So you have to multiply every term by 6x. Again, we have to multiply every term by 6x. So that'll be 6x multiplied by 1 over x, then 6x multiplied by 1 over 2x, and then we have 6x multiplied by 3x, and then we have 6x multiplied by 5 over 3. Alright, so now we can cancel out, right? Can we not?
Yes, sir.
And so we can say x cancel with x, yes or no?
Yes, sir. All the x cancel over each other.
Good, all x cancel off each other, good. Okay, so also we can have this x with this x, right?
Yes, sir. All the x's with each other.
And then this, how much times 2 goes into itself?
One time,
1 time. How much times 2 goes into 6?
3 times.
3 times, good. And then here is going to be x and x. How much times 3 goes into itself?
One time,
1 time. How much times 3 goes into 6?
Twice.
twice.
Good. And then we have 3. How much times 3 goes into itself?
One time,
1 time. How much times 3 goes into 6?
Twice.
twice.
Good. And so the next thing that we do is we make sure I put our equal sign. No, we don't have to put the equal sign. This equal sign right there. We say 6 times 1. What is 6 times 1?
6.
Very good. Minus. We have 3 times 1. What is 3 times 1?
3.
3.
Good. Plus. We have 2 times 1. What is 2 times 1?
2.
2. Very good. Equals. What is 2
10.
times 5?
10.
10. And we cannot forget our x right here.
X.
Okay. Good. And so now we have 6 and 3. What is 6 minus 3?
3.
3 plus 2 equals to 10x. So 3 plus 2 is
5.
5, which equals to 10x. Okay, here we divide both sides by
10.
divide both sides by 10. Divide both sides by 10. And this will cancel out with that, leaving us with simply x is equal to, what is 5 divided by 10?
12.
Yeah, 5 goes in itself once, and 5 goes into 10 twice. So that's going to mean that means that x is equal to a half. We could switch it. X equals to a half. Okay, and that is the correct answer.
I understand. Oh, Mr. Petit, I did understand this. I just was confused with the first part where we saw that with that one minus one thingy, but then I was incorrect.
Say it again.
I say I was confused with the wrong thing. I was mixing up with the one which you say was incorrect, where we did do the one
Oh,
minus
okay.
one, where we didn't bring down the six.
Okay, 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 okay. Yeah, I'll be alright. Okay. It is a factor. Alright. That makes sense. I know. Okay, so should I stay at this for some more? Or y'all got it already?
Got it.
You got it? You got it?
I'm done.
Okay. Alright. Okay. Okay, so we good with that. Next up is so we basically finished that, so that's good. Let's look at this so that we finish this one with a bunch of equations. Um, Now let's go to this one. So this one, what do we have? This is how much sides does the shape have?
Four,
Four.
four.
This is one. This is two. This is three. This is four.
4.
That's good. So it's a quadrilateral, right?
Yes, sir.
It's made up of how much triangles?
Two.
Yeah, you can see two triangles. All right, so that's important. Okay, I feel I thought someone was done. Okay, so we have two triangles. I thought that it sounded like someone was trying to join. Okay, so for the quadrilateral, so quadrilateral means four-sided figure. For the quadrilateral ABCD, where AB is 51, AD AD is 102, AD is 102, AC AC is 93, and the angle ABC, which really is this angle B right here, is 114. So this angle B here is 114, and this angle CAD right here, angle A is 36. So they say giving your answer to the nearest whole number, calculate the length of CD. The length of CD. Okay. All right. I would admit this one might be a little unfamiliar to us, but let's still try to tackle it, and it's for 4 points. So we want this length CD. This one is missing. But we have to notice that if we look carefully, right? So we want the length we want CD. Let me show you excuse me, let me show you something. Look at this. If we look carefully at this, right? We notice that um this is a triangle right now. So this right here is a triangle. We can see that, right?
Yes, sir.
So basically we are dealing with a triangle, so let's make it noted right there. So I'm taking this triangle and I just represent it by itself. Okay? So this is the triangle that we have. This is C. This is D. This is A. Okay. All right, good. This is 36 degrees. Now we're trying to figure out what is the length of CD. And we are given that this is 93 centimeters. And this is 102 centimeters. So how would we figure this out? Any ideas?
So you subtract the 93 from the 102?
No, you don't know. That's not how it's
A
gonna work.
squared plus B squared equals C squared.
Well, that's Pythagoras theorem. That only works with a right angle triangle. Anyone else?
You wouldn't add them and subtract it from something?
No. No. Here we're gonna use the sine rule. Now, Nancy said, use Pythagoras theorem, but Pythagoras theorem only applies to someone mic is on.
Mr.
Pythagoras theorem only applies to right angle triangles. This is not a right angle triangle, so we can't use Pythagoras theorem. We have to use the sine rule. Okay, and so if this is capital A, then this right here would be small a. If this is capital C, then this right here would be small c. If this is capital D, then this right here would be small d. All right, and sine rule basically tells us that, let me just show you an image so you can see exactly what it is when I explain it. This is very useful. Sine rule comes a lot. And sorry, not my, sorry, sine rule. Sine rule. So this is very important. Let me find it. This is a good one. So this is sine rule. You have sine rule and you have cosine rule. Both of them are useful and important. We could use either one for this one. Okay, so but I'm more familiar with sine rule, and I think sine rule is
Can I
easy.
get the question, please?
Say it again.
Can I get the question when you finish, please?
Okay, I don't like that image. That image is too small. Okay. All right. Let's see if they give us a better image. I just want a good image of it. Something that's nice and clear. That ain't clear. That's kind of blurry. Okay, we just have to go with this one then. So this right here is the sine rule. Let me see if
We did this before.
we did. Yes, we did. Okay, so this is the sine rule. So the sine rule says that sine of capital A over A is equal to sine of capital B over B is equal to sine of capital C over C, and vice versa. So let me show you what I mean by vice versa. So if we have, let's see if we get a better one. Okay, this is a good one. I like this image, even though it's blurry. But they say that it don't have to be a right angle. All right, and that's the truth. It doesn't have to be a right angle. Let's see if we give this picture. Okay, this one works. So I think this one does the job pretty good. I think this does a very, very good job at it. So we can keep this one. So what this one is saying is that if we look carefully, this is capital A, right? You see that? Hello?
Yes.
This is capital
Yes, sir.
A. And what capital A refers to the angle. Okay? Capital A refers to this angle right there. That's capital A. Small a refers to this side. Okay? That's what small a refers to. So whatever capital A is, if it's this angle, that's going to be capital A, and its corresponding side would be the lowercase letter. So you use the uppercase letters to denote the angles and use the lowercase letters to denote the side. Similarly, we have capital B here, right? Capital B. And so capital B is denotes this angle, right? And then the corresponding side would be small b. You see that? So the side here is small b. And then here capital C represents this angle here. And then small c would represent the corresponding side. So it'll be this particular side right here. So they're saying that if you take the side small a and divide it by sine of the angle, that's going to be equal to taking the length of another side and dividing it by sine of that side. That's going to be equal to taking the length of one side and divided it by sine of that angle, the corresponding angle. Or you could flip it. And you could say, well, take sine of the angle and divide it by the corresponding um, side. Or you could take sine of another angle and divide it by the length of that side, and those two ratios are going to be equal, and it's also equal to this one. Okay, so this is what the sine rule says, and using sine rule we can find the length of sides or missing sides, and we also can find the measure of different angles for any triangle. It doesn't have to be a right angle triangle, for any triangle. All right. Okay, so someone said they're trying to get in. Okay, so that's the rule. So using this rule, that's why I was able to say that this is capital A. And so since this is capital A, which refers to this 36 degrees, the corresponding side is going to be small a. And this is capital D. So the corresponding side is going to be what?
Lowercase d.
Lowercase d. And this is capital C, and so the corresponding side is going to be lowercase c.
Lowercase c.
Now, don't be confused. You might say, well, Mr. Petit, here they use A, B, and C. But in your triangle, you use A, C, and D. Is it still the same?
Same thing, right?
Still the same, okay? We just change the letters, but the idea stays the same. Okay, so we're going to use the sine rule to find the missing side. So this is the missing side that we're using. So the missing side is A, and so we're going to say capital A divided by sine of, oh, I think I see the problem now. We do not have, what do we need it? We just need a, oh, okay, I see the problem now. The problem is we do not have we probably might have to end up using cosine rule, you know, because here we only have one angle. And we only have one angle.
36.
We only have one angle, 36. We don't have another angle inside the same triangle. Yeah, and in order to use the sine rule for this one, you can need, the only thing that we need to be missing is we need a side to be missing. And here we can't have a side missing, only a side, because here there's more than a side missing. A side is missing and an angle and another angle is missing. So say for example, this is the side that's missing. We needed the angle for C or the angle for D in order to use the sine rule. So I just now see that sine rule wouldn't work. Because, let me explain why sine rule wouldn't work again. I thought it would have worked for this one. But the problem is that we have an angle, you know. We have one angle, but we need at least another angle here or another angle here for it to work. So sine rule wouldn't work for this. Then my only other guess would be cosine rule. So let's see cosine rule. Let's see if we have everything for cosine rule. You can't do sine rule, so Let's check cosine rule and see if that works. So cosine rule says that we need the length of all the sides. Do we have the length of all the sides? No. Oh, okay, perfect. Cosine rule will work. Yeah, cosine rule will work. Yeah, all right. So here they want us specifically to use cosine rule, because sine rule wouldn't work. So cosine rule says that, copy image. So this is the better one. This is the one that we should be using. Cosine rule. So cosine rule tells us that, again, if we have if we have this capital A, small a would be here. If we have capital B, small b would be there. If we have this as capital C, small c would be here. And cosine rule tells us that if we take this side and square it, and if we take this side, if we take this side and square it, that's going to be equal to, if we take this side and square it, plus if we take this side and square it, minus twice b. B is this side, multiplied by c. C is this side, times cos of an angle. And here, cos of A. Okay. All right. So this is what we're gonna use, and here it's perfect to use because we have everything that we need. And so here we're not gonna use sine rule. Let's use cosine rule. Okay. So my apologies for that. Let's use cosine rule for this one. So let me copy a rule. So we're gonna use. I prefer to use this rule. To use the rule this way. It just feels more natural because then we have to figure out what A. We have to figure out what A is, right? So yeah, let's use this. Let's use the first one. The first one is better. Let's use the first one. It's just easier. Okay, good. All right, so okay, good. So this is the cosine rule. That's what we're gonna be using for this one. All right. Okay, so this is capital A, isn't it? So capital A
Yes.
is gonna be equal to 36 degrees. That's the first thing. The associated angle A, the associated side A, because if this is capital A, this side here is going to be small a. So that side we don't know. That's what we're trying to figure out. We don't know that side. We don't know that. B squared. Now here we can use, here they use B squared, right? But here we have D. Okay, here we have D. So we have to change this B squared into D squared. We have to change it to D squared because our image don't have no B in it. It have D. So we have to change this to D squared. So it's going to be small d. So small d is going to be equal to what? 93. And then here they have c. C squared is C is going to be 102. So c equals 102. Okay, so now I think we all set. A squared we don't know, so it's going to be a squared going to be equal to, what is b squared? What is d squared? Well, d is what? 93. And we're going to square it. Plus, what is c squared? Well, c is 102.
102 squared.
102 squared, yeah. Good. minus 2, what is B? So not B, we gotta use D, right?
D is 93.
D is 93. So 93. Good. What is C? C is
102.
And then we have to take cosine of A. So it's gonna be cosine of, what is A? A is
36.
36.
36.
Good, 36. Good. And so we have to say that A squared now is gonna be equal to, what is 93 squared? So calculator. 93 squared is what? 93 all squared, right? Plus 102 squared. It's gonna be equal to 19,053.
Yes.
It's gonna be 19,000. 19,000. So these two combined gives us the 19,053. Okay, minus we have 2 times 93 times 102 times cosine of 36. So let's do 2 times 93 times 102 first. So 2 times 93 times 102 is going to be equal to
18,900.
Yeah, 18,092.
18,972.
Yeah. So all of this is going to be equal to 18,972
72.
cosine of 36. Okay, so now a squared is going to be equal to 19,053 minus, now we have to do 18,972 times cosine of 36. So let's do that.
How are you supposed to do that? Just 1993 that number times 36.
No, 18,972 times cosine of 36. So we have to make sure that our calculator is in degrees. So
Oh, so you have to use calculator for that.
you have to. So it's 18,000. And I have to make so. Hey, you see this is in radians, right? I have to make sure the calculator is in degrees. If it's not in degrees, I'm gonna get the wrong answer. So I need to make sure my calculator is in degrees. If I kept it in radians, it would have been wrong. So make sure your calculator is in degrees when you enter the test. For those who have tests with calculator, make sure it's in degrees.
So, Mr. Batit, I can't do it with pen and pencil, right? I have to use a calculator.
Yeah, you have to. You can't do the pen and paper unless you do. Unless you no, you can't do a pen. Not right now. It has a long way to do the pen and paper that you don't need to know right now. 18,972.
So I don't have to know that for the BJC?
18,972.
Okay.
18,972. Okay, good. 18,972. And then cosine of what?
36.
Cosine of 36. Close bracket. And so we get 15,348. We'll just do it to 2 decimal places. So it'll be
67.
So all of this combined. Let's use a different color, say purple. So all of this combined gives us what it was, 15,000 something.
15,348.
Uh-huh.
And that's all I get.
Point what?
I didn't get the point card.
Point something. Point
62, but I ain't sure. I'll double check
67.
that.
I think point. I think it's point 67. Yeah, 15,300.67. Now here we have a. This is a squared, but we don't want a squared. We want you know what, first, even before we do it, let's subtract before we even consider that. So this is a squared equals to so it's gonna be 19,053. So we have 19,053 minus 15,348.67. So that's 19,053 minus 15,348, right? What do you get? What do we get? 3705. Say it again.
3705.
Yeah, 3,000. 700. 54.
And 5.
No, 0.33.
I calculated and I get that.
Yeah.
I got 3,705.
No, he's not supposed to, because you put 0.67.
Oh, okay. Yeah, I didn't put the 0.7. Okay.
So 19,053 minus 15,348.67. Now we know that this is a squared. So we don't want a squared, we want a. So in order to get rid of that a squared, what are we gonna do?
Divide.
Not divide. To get rid of the a squared, what do we do?
Square root.
Square root both sides. And so this square would cancel out with this square. So the square root would cancel out this with this square. And so we are left with simply a is going to be equal to the square root of 3,704.33. So the square root of 3,704.33. So let me do that. So we're dealing with the square root of 3,704.33. Alright? And that gives us what? 60.86.
60,832.
No, 60.86.
I got that too.
Oh, yeah.
So it's 60.86. So A is going to be equal to 60.86. And so that's how you would do it. Any questions for me?
No, sir.
No? Familiar, unfamiliar, easy, hard? Let me hear from you.
This a
Who said that?
one.
Oh, I just came back and jeez.
uh, well,
You mind doing another example?
ah, you funny, but we ain't gonna do another example of this. I can try go to a more familiar one, and then I can come back to this question. But I think it's our first time ever doing cosine rule in this class. So
We did do sine.
we did do sine rule, we never did cosine. So
Yeah.
cosine rule is this formula. This one you have to remember when you're trying to find a missing side. Um, when you're trying to find a missing side, and they only give you a few information. Okay, so this is it. So become familiar with this rule, and also sine rule too. Those two are important. Okay, so let's go back to familiar territory before we have persons crying in here. Um, okay, let's see. I think. Okay, good. No, one moment. I'm trying to. Okay, we go. Okay. All right. So we did the 2021 paper. I want the 2020 paper. So let's do this one. Okay, so these should be familiar questions for us. I can start from the back. Okay, so starting from this paper one or paper two. This stuff like paper one. I'm really trying to avoid paper one. Oh, paper two. Okay, that's good. Okay, good. So this one should be very easy for us. It says Mr. So this one is filling out a bill. Okay, and so we should be familiar with stuff like this. So we're gonna do it step by step. So all right, so let's consider it. So it says Mr. Green bought the following items from the food store. Calculate his total bill. So he bought 5 apples for $1.09 each. So how would we figure out his total?
Add.
Multiply
Multiply what?
109 by 5,
Very
right?
yeah. 5 times 109. 5 times 109. And what is 5 times 109?
$5.45.
$5.45.
Huh?
Okay, good. Good. So its total for this one is gonna be $5.45. Oh, by the way, send in the notes for the cosine rule, please. I want to see how y'all did that question. Please send in the notes for that. Okay, so the next thing is we want in fact, let me let y'all do the rest and tell me what your total is, and then we can check it. Let me give y'all 2 minutes to do that. Do the rest, and then um give you 2 minutes to do the rest, and then we can check it together. This one should be straightforward. Any answers yet?
For the second one, I got not $3.96.
You say
$3.96.
I mean for the total. Any answers for the total?
Yeah, $25.
In total? Okay.
Yeah, 25.44.
Okay.
$25.40.
25.40. I thought you got one.
No, I get $25.44.
44. Okay.
Mm-hmm.
So someone got 25.44. Next person got 25.40. Anyone else? Anyone else? Okay, so let's do it. So we know that um for apples we have 5 times 109. For the oranges, there are 8 oranges, right? So there are 1, 2, 3, 4, 5, 6, 7, 8 oranges. And we know that 2 of these oranges is for 99 cents. So that means that this 2 is for 99 cents. Or you could say basically $1. Then we have this 2, which is for 99 cents. Then we have this 2, which is for 99 cents. And we have this 2.
I get $31.36.
$31. Okay. I seen all type of answers. Here and all type of answers. It's supposed to be a pretty straightforward question. So this is 1, 2, 3, basically. So let's do it. So we have to add all them up.
Excuse me, but did you want our answer?
Yeah, I want the answers.
Oh, sorry. I didn't notice. I got 25.40.
25.40. So for this one, we have to take
I got 25.44.
25.44. Who said that?
Macario.
Macario. Macario. Oh, Macario Dean.
Yes, sir.
Okay, good. I don't be getting notes from you, Macario.
That's my fault.
Yeah.
My bad.
Please send in the notes. I'm glad you spoke. You know, that's good. Okay, so 0.99 times 4 is gonna be what? 3 point what? 96?
Yes, sir.
So 3.96. And we have here one watermelon for $15.99 each. But we only got one watermelon. So that means it's just gonna be 1 times
15.99.
15.99. Yeah,
Which is the same answer.
which is the same thing as 15.99. Very good. So it's gonna be 15.99.
Excuse me, Mr. Petit.
Go ahead.
What BJC page this is?
2020, paper 2.
Okay.
So 545 plus 396 plus 1599 is 25,
2540.
2540. So that's the correct answer, 2540. So where did we go wrong for the people who got 44, 25, 44?
I got the 2 for 99 cents.
Me too.
Okay. Yeah, that's why I
I
like.
didn't multiply by 99. I didn't.
What did you do instead?
I have 99. I don't know how I get that wrong, but.
So
I
what
think
you
he put as a dollar instead of
Oh.
99.
Oh, you
I don't know what.
At first I had 99 times 4, and then I gonna change it to 99 times 8. I don't know why, but.
Oh,
Yes.
no. Remember, that's why I do the circles. 2 for 99 cents. So 99 cents, 99 cents, 99 cents, 99 cents. So 4 times.
I thought the 396 was too low, so I changed it. I know why.
Oh, okay. I understand. Alright, so that's that. 17. Okay, let's do one more of the familiar questions and then we could go to our probability question. Remember that probability question that we're supposed to do? Supposed to finish up. We can go to that. Okay, I like this question. I like this algebra question. Algebra is our favorite. Right?
Yeah, sure.
Good. Awesome. Okay, so when I was a student, I didn't like these algebra word problems. I hated them with a passion.
I don't like them either. I have to do that.
Write an expression for each of the following. Patrice thinks of a number, call it x. She multiplies it by 4, then subtracts 3. Wait, give me one moment. Let me see if someone is trying to ask to join. Okay, no. Okay, so she think of a number. Patrice thinks of a number, call it x. She multiplies it by 4, then subtracts 3. So write an expression for that. What's the expression going to be? Anyone?
X times 4 minus 3.
Come on, do it better than that. Clean it up.
4x minus 3.
4x minus 3. Exactly. 4 times x minus 3. Why? Because she thinks of a number, call it x. We multiply it by 4, right? That's what, when we have them combined together, that means multiplication. So she thinks of a number, we multiply it by 4, so 4 times x. Then we would subtract 3. So 4x minus 3 is correct. Any questions on that?
Easy 2 points.
Easy. Say easy. All right, Lionel. Okay, so next up is this one. Angelo thinks of the same number x. He multiplies it by 2, then subtracts 7.
2x minus 7.
Say it again.
2x minus 7.
2x minus 7. Let's see. So he thinks of a number, the same number x. He multiplies it by 2 and subtracts 7. Yes. 2x minus 7. So he thinks of a number x, multiplies it by 2, So that's 2x. Then subtract 7. It's definitely going to be 2x minus 7. Good. Now, so the first one was 4x minus 3. The second one is 2x minus 7. Now they're saying to us, it's a very good question. The two expressions are equal. Form an equation to show this. The two expressions are equal. Form an equation to show this. What would we do?
4x minus 3 is equal to 2x minus 7.
Does anyone agree with her?
Mm-hmm.
Anyone else have a different answer or? Anyone else? So we have this one 4x minus 3 and this one is 2x minus 7. And she's right. We have to equate them to each other. So
I get the question, please. Sorry then.
okay, yes. Discard the two expressions are equal. Form an equation to show this. Where are we? Someone's asking to join. Alright, welcome Abigail. Let me take the register. Saying that she comes, she can. Abigail and Adrian Collins, please send in the notes. If you haven't sent here or present in the chat, please do so. Alright, please do so. We have a lot of people missing tonight. I don't know what happened tonight.
Yeah. Yeah, today is like a stock. Like it's just dropped. We went from 20. We went from 50 to 21.
Yeah.
This week wasn't that much.
No. Only the strongest survive. We have a lot of people missing. Kennedy missing. Nixon.
Alicia.
Who? Alicia, yeah. 4x minus 3. 4x minus 3 is going to be equal to 2x minus 7. So again, 4x minus 3 equals to 2x minus 7. So they are equal. So that's the equation to show that they are equal. Okay, and for that you get your mark. Now, here they are telling us to, here they're telling us to solve the equation to find the value of x. So you want to solve the equation to find the value of x. Excuse me, how would we do that? So here we want to use the same equation and we're going to solve for x. What's the first thing we're going to do to solve for x?
Carry all the x on one side.
Very good. So that means we're going to send what over?
The -3.
Okay, where are we going to send that over?
Behind the 7.
To negative 7, yeah.
And then what else are we going to send over?
2x.
2x to 4x.
Good. So we are now with, I think someone's trying to join now. So this is going to be 4x minus 2x. It's going to be equal to, remember we put the minus because why?
Carry it over.
Yes, because once you carry it over, it becomes a minus. And it's going to be negative 7. This was a pause. This is a negative 3. So when it comes over, what does it become?
Positive 3.
Positive 3. Good. So it's going to be 4x minus 2x. What is that? What's
2x.
2x. Very good. Equals to, what is negative 7 plus 3?
Negative 4.
Negative 4.
Negative 4. We divide both sides by what?
2.
Divide both sides by 2. Very good.
And your answer is 2. Negative 2.
X is going to be equal to, what is 4 divided by 2?
Negative 2.
Good. Okay, so x is going to be equal to negative 2. And it shouldn't make sense because think about it. 4 times negative 2 is negative 8. Negative 8 minus 3 is negative 11. So it'll be negative 11 on this side. And if we say 2 times negative 2, that's negative 4 minus 7. Negative 4 minus 7 is negative 11. So on both sides, we get negative 11. So this is correct. X is negative 2. So the number that they were thinking about is negative 2. So we already formed an equation to show this. Now, like they said, so this answer with the working applies to this one, C. Solve your equation. Solve your equation. So the first part is just writing out the expression. That's the first line. That's the pi set. But the next part is solving the equation. That's this.
Hello?
I'm here.
Just gonna say what on that.
What happened? I'm here. Just giving y'all time to write.
I was writing with you.
Okay. Okay, so send that in. Thank you, Sean. Very good. Thank you, Sean. Anyone else? Send in the notes, please. Thank you, Miss Keisha.
You want to send them to the right too for it?
Yes, sir. All right, good. All right. Okay, so what else do we have? Okay, so let's go back to the probability. Okay, so this probability we started and we just trying to figure out two members are chosen one after the other. Calculate the probability that they are both right-handed. So this one, the way how we do it is the following way. We have to take into account what happened previously. So what I mean is, let's go back this and let's pull this up. Remember last night when we was doing this, we saw that how many girls was left-handed? In total that there are 18 girls. So if 15 are right-handed, 3 would be left-handed. And how much boys you saw with
9.
9.
9 boys.
Good. So now the question is, two members are chosen one after the other to represent the club. Find the probability that they are both right-handed. So the probability, let me allow this person to join. So the probability that they are both right-handed, so probability that both right-handed, so probability of both right-handed is going to be equal to
24 over 30.
Is going to equal to the first one, the probability that the first one is right-handed times the probability that the second one is right-handed, given that the first one is right-handed. So it's going to be equal to the probability that we get one right-handed multiplied by multiplied by the probability that we get one.
Another.
So second right-handed, given that the first is right-handed. This is something very interesting to consider, that first of all, we're going to multiply these two probabilities to get the answer, but the idea that I really want you to understand is that we are, especially for the second part. Okay, let me squeeze this in. I gotta reduce this. So, okay, good. So this first part says that the probability that both is right-handed is going to be the probability that we get one right-handed times the probability that we have the second one is right-handed, given that the first is right-handed. So we have to take into account that the probability of, like, we call these two events, when you see something like this, we call these two events, we say that they are dependent, right? So these are dependent events, right? So the probability, when you have dependent events, is that, like, the probability of one affects the probability of the other. So the idea here is that when we go here, the idea is that this second event, right, is affected by the first event. Because once we take out, remember, we're trying to get the probability that both are right-handed. Once we take out the first one, who is right-handed, we don't still have 30 people. So this probability would be affected by the first event. So we call these two dependent events. That means one event, the probability of one event is affected by the probability of the other. So one event affects the other. So what I mean is that when we consider this, the probability of us getting one person right-handed, well, we know that right-handed people is just going to be 15 and 9. So it's 15 plus 9. And what
24. 24.
15 plus 9 is 24. So we know that out of the sample space of 30, the sample space contains 30 individuals. There are 30 individuals to choose from. Out of the 30 individuals to choose from, there are 24 people who are
24.
right-handed.
Right.
And then we have to multiply, but we have to consider when we're multiplying that the first one is already chosen. So do we still have 30 people to choose from?
No, it'll be 29 over 20. I mean 23 over 29.
Yeah, we only have 29 people to choose from. Right? Now, not only do we have 29 people to choose from, but we already chose someone who was
Right-handed.
right-handed. So we don't still have 24 people who are right-handed. We actually have 23 people who are right-handed. And so now that's correct. So, and something interesting to consider is that what? This probability is affected by the first one because we had to take into account that we did take out a person, a right-handed person. So yeah, we had 24 right-handed persons, but we already took one. So that leaves us with 23 right-handed individuals. And yeah, we had 30 people at the beginning to choose from, but because we already took one out, we are left with 29 people. So we have to take that into account as we consider this probability. So they are dependent events. Now we say what is 24 times 23? 24 times 23. 24 times 23. Someone?
552.
552. And what is 30 times 29? What is 30 times 29?
870.
870.
870.
Good. Now at this point, we could represent probabilities as decimals as well. So if this is me, I would represent it as a decimal. What is 552 divided by 870? We get 0.633, whatever. Okay, in that case, let's not let's not represent it as a decimal because it's just going to be too long. So what can 552 and 870 both be divided by? Evenly. Hello?
Mm-hmm.
Hello?
I'm trying to figure it out.
Nine.
9. 9?
That's what I said.
9? 552 could be divided by 9? No, not evenly.
5.
6.
How about 12?
Mm-hmm.
12 will work, right? But
12 won't.
Yes, sir.
Plus 8.
but
12
12
won't work for 870.
12 won't work for 870.
How about two?
How about too small? Let's use 6. 6 could work for both of them.
Yes, 6. I said it was 6.
So divide this by 6. Divide that by 6. So for the top we get what?
92.
Yeah, 92. For
For
the
the
top
bottom we
one.
get what?
145.
145. Can we simplify it further?
Yes, sir.
What number?
3. Wait, no, it can't.
What number?
Because the top is even and the bottom, and the bottom is odd, so it can be simplified.
We can't simplify it further.
Yes, sir.
So 92 over 145 cannot work. So that's the answer. Now, you said because the top is even and the bottom is odd, that's why we can't simplify it further.
Yeah. The way I look at it, yeah.
Well, let me give you a good
3
example.
over 9 to simplify though.
10 over 15. The top is even, the bottom is odd. We can simplify that further, right?
Yep.
If we use 5, right?
Yes, sir.
Yeah. So just because the top is even, the bottom is odd, that doesn't necessarily mean that it can't simplify. The reason why this cannot simplify is because this is a multiple of 5, but this is not. You see the problem?
Yes, sir.
Yes, sir.
And we cannot think of a number that could go on both of them evenly. I can't think of none right now. So
No, honestly.
yeah, I think once the GCD of these two numbers is 1, then we're good. So let's see. Greatest common divisor of, so let's see the GCD of 92 and what it was, 145. If it's 1, we're good.
Yes, sir, it's 1.
It's 1.
Yes, sir, it's the largest number that is divisible by both numbers is 1.
No, that's not it. Let me see.
I Google it and it's 1.
It's a 1. Okay, so 145 and 90 what? 92 is what we got?
Yes, sir.
Yeah, the GCD is 1, so we're good.
See, I knew that.
Alright, so 92 over 145. So here you had to take into account for this probability, you had to take into account that the first event happened. Alright, so that's very important for this probability. Excuse me. Kennedy. Hey, Kennedy.
Good evening.
Yeah, glad you're on time. What? What happened?
Practice.
Practice? I just say glad you're on time. I don't know. You know why you giving excuses. I say glad you're on time. That's a compliment. Alright. Okay, so here we are on the calculated probability that two members are chosen to represent the club. Calculated probability that they are a boy and a girl in any order. Okay, so in any order. So it don't have to be a boy first and a girl or whatever. In any order. So remember we had the table was 3 and here it was 9.
9.
So two members still are chosen though. Okay. So we want to figure out the probability that we get a boy and a girl in any order. So we have to be very careful. So what are the two ways that this could happen? This could happen in two ways.
Yeah, a boy and girl and boy.
Say it again. So the first way it can happen, so one way is that we can have a boy first, then
Boy and girl, and then girl and boy.
yeah. So first we can get a boy first, then girl, and then the second way is that we can get a girl first, then boy. So the first thing we're gonna do is we're gonna do the first way first. The probability that we had a boy. So probability that we have boy, then girl, and that's gonna be equal to the probability that we get a boy times the probability that we get a girl given that we first got a boy. So this is gonna be, how much boys do we have altogether?
12.
12 boys, good. How much people do we have altogether?
30.
30. That's 9 over
30.
good. And so we're gonna multiply that by the probability that we get a girl given that we first got a boy. So remember we said that we have to be very careful with things like these, because remember that do we still have 30 people to choose from?
No, sir.
No. How much people do you have to choose from?
Boy and girl.
No, like how much we already got a boy. So
Oh, girl.
no, I mean like in the total population, right? We remember
You would have 12 minus 30 remaining.
No, let's leave with the bottom. First we had 30 people to choose from, right? That was the amount of in our sample space. We had 30 members.
18?
No, think with me. Like we chose a boy. So how much left? How much people do we have to choose from now?
But it still be 29?
Yeah, it'll be 29. Because we had 30, we chose a boy, so we can't still have 30 people left. We have 29 people left. Now, out of that 29 people, we have to choose a girl. So
11.
how much girls do we have?
11.
11. Why 11 girls?
Is it 18?
Still 18. We didn't choose a girl at the beginning. We chose a boy at the
Oh.
beginning. Sound like I need to do this over again, because I don't think y'all got it.
No, I understand it now. We didn't pick up.
Yeah, we didn't pick a girl. So remember, so the first way we could get it, right? Because we're trying to get a probability that we chose a boy first, then a girl. Now, the first way that this could happen is that we could get a boy first, then a girl. Okay? Now, the probability of getting a boy is going to be the amount of boys that we have, which is 12, because 3 plus 9 is 12. There are 12 boys that we have, divided by the total number of people in the group or in the club, which is 30. Now, remember, it's probability of boy then girl. So we have to choose a girl now, but we don't still have 30 members. We already chose a boy. So we only have 29 members left. And out of that 29 members, we need to choose a girl. And from here, we know that there's 3 plus 15 girls, so it's gonna be 18 girls altogether. So it's gonna be 12 over 30 times 18 over 29. And that's gonna give us what?
216 over 870.
216 over 870. Anyone want to second that?
216, not 16.
216, 216. Anyone want to second that? No one?
Over 870.
No one? Hello? Hello there? Hello?
Trying to solve it. Hold on a minute.
Okay. Okay. So we have 12 times 18. What is 12 times 18?
216.
216. And what is 30 times 29?
870.
870. So we got 870 there. So that's the first way that we could do it. Then we have another way. Another way that this could happen is if we get a girl first, then a boy. Isn't it?
Yes, sir.
So we want to get a girl first, then a boy. So how will we do that? So it's going to be a probability of getting a girl, then a boy.
Will it be the same thing?
You think they'll be the same thing?
You just put 18 first.
So let's see. Well, let's see. Let me expand this some more. Maybe if I can expand this some more, that'll work. Okay, good. So let me move some important points. Let me move this. Good. So we still have 30 people to choose from, isn't it? But we're trying to choose a girl. So how much girls do we have?
18.
18 in total. Then a boy. So we're trying to choose a boy this time. But remember, we already chose a girl, so this will be 29. But how much boys do we have?
12.
12. Good.
Same answer.
And so what is 18 times 12?
216.
216, 216. And what is 30 times 29?
870.
870. Okay. Now we're almost done. So the probability, remember they said that probably boy and girl in any order. So probability that we get a boy and a girl. So a boy and a girl in any order is going to be equal to 216. What do you think we're going to do with these two fractions?
Divide them. Right.
Divide them? Divide them. Certainly not divide them. Remember, it's one way or the other.
Multiply.
No, when we have or, what do we do?
Add.
Add. So it's one way or the other. So it's going to be addition. So 216 over 870 plus 216 over 870 is going to be equal to still 870 as the denominator. But what at the top? 4, 3.
432.
Good. 4, 3, 2. Okay, so that's how we get it. Now, can we simplify further?
No, sir.
Yeah, we have two even numbers.
I'll take my.
So that'll take long. We have two even numbers. Let's see. Let's see. 6, 12. Well, we know. Let's 6 again. 6 again will do it. We'll do the trick. What is 870 divided by 6? We saw that last time. 145.
145.
So if we divide by 6, it's gonna be 145. And if we divide 432 by 6, what do we get?
72.
72. Can I simplify further?
No.
No.
When Sky, what number did you divide it by?
6. So divide top and bottom by 6. All right. Easy, hard, difficult, familiar, unfamiliar. What are your thoughts on this question?
Very unfamiliar.
It was good. It was easy, but them simplifying part, they just too long.
Okay. Anyone else? What are your thoughts on this question? No one else? Everybody else quiet tonight.
Unfamiliar.
Unfamiliar. Okay. Yeah, that's probability on steroids.
Bro, what?
Yeah, but the idea is the same. But to be honest, in the spectrum of questions, in math, these are easy probability questions. So don't worry. These are the easy ones in the spectrum of questions for probability. Because trust me, probability questions could be so intense, man. I remember it was from undergraduate days. My probability that wasn't playing at all. But thankfully, you all have some easy. These are very easy to deal with, I must say. For the Bgcse and Bgcse, they don't do you all bad. They give you very manageable questions, so that's good. Okay, any questions on this before we go?
No, sir.
All right, so let's continue. Okay, so good. So let's go back to our familiar territory and let's see what we could get before the time run out. Look at what we have. A time graph.
Can I get us that?
It's easy. We love time graphs, don't we?
No, we don't.
No, we don't. These are easy.
I mean, it ain't a problem.
It's just so much work. Oh my god.
Time graph?
Freaks me out.
Wow, time graph is so easy.
It's easy, but
It's too much drawing just to be seen.
Too much. I mean, yeah, y'all have to write down notes, but
But we gotta draw that?
what do you think?
Oh, we just gotta look at the screen and answer the
You gotta
question.
look at the screen, not draw it. Don't worry.
Y'all are gonna draw it no how, so I don't even want to waste my time. But at least write the questions down. Okay, so
Okay.
at what time did the journey begin? At what time?
8,
8?
2,
No.
10 a.m.
No. Think about it. This is
9 o'clock?
9 a.m. Yes, because
9 a.m.
this is 11 a.m. And think about this is 10, right? So they go from 10 a.m., 10:30, 11,
Oh,
11, 11:30, 12, 12, 12:30, 1, 1, 1:30, 2. So all you gotta do is go back. So it's gonna be
I didn't look
9:30.
at the rest. I just look at 10 and say 9. And then 8. I just say 10, 9, 8.
You gotta be paying attention, Miss Cooper. Have to. So 9 a.m. Okay, so the journey began at 9 a.m. That's the time the journey began. 9 a.m.
You have to draw the graph.
Uh-uh.
Please, no.
Okay. Next up, how far is Gully to Island? Man, I wish they would use some sensible names here, you know. Like, come on, how much sensible names in the Bahamas? They could say, you know, Bacardi.
Yeah, bro, it's
You know, like, come on, like, this is the BJC. Come on, make it Bahamian-ish. I don't know, my people.
I agree with you.
Anyway, how far is Gully to Elan?
70? 70 kilometers.
Yeah, 70. Very good, because we start from here. No, yeah, 70. So, this is gonna be 10, 20, 30, 40, 50, 60, 70. Very good. Why not 80? Why didn't we go up to 80?
He reached there.
Good, because the
Plus, it's a
graph,
line because it's a yeah.
yeah,
I mean, he stopped.
yeah, the graph is right here. So,
So is it 70? That's kilometer.
say it again. It's 70 kilometers.
70.
70 kilometers. 70 kilometers. All right. How long did the car stop in Eland? So that'll be
From 12:30. I mean, from 11:30.
yeah. So the car stopped
11:30. An hour.
this is 11:30.
1 hour.
To 12:30. 11:30 to 12:30. And
1 hour.
1 hour. So the car stopped for 1 hour. Good. Now, how long did the journey how long did the entire journey take? Do not include the stop. Okay, so how long did the entire journey take? So this is going to be from 9 to 10 is 1 hour.
Yeah.
From 10 to 11 is
2 hours.
1 hour.
Go flip.
From 11 to 12, 1 hour. From 12 to 1 hour. And from 1 to 1:30, 30 minutes.
30 minutes.
30 minutes.
So
4 hours.
we
30
have
minutes.
1, 2, 3, 4. So we have 4 hours and 30 minutes.
And 30 minutes minus an hour.
Yes, but we have the minus an hour because we have the minus our stop, because they say don't include the stop. So this is gonna be minutes. So 0 minus 0 is 0.
0,
3 minus 0 is
3,
3. And then 4 minus 1 is
1, 3.
3. So here we have 3 hours. 3 hours and 30 minutes. So
That's the only one I would have get wrong.
why?
Because when you was counting, I thought you did exclude the stop. So
Oh, yeah, I counted everything and then afterward I exclude the stops. So 3 hours and 30 minutes. Okay, see how easy that was? That's why I say the time graph, it don't take us a minute to do. It just easy
we
points.
got help. That's good. There's so much easy.
All of them is easy. All of them are easy. All of them.
Cough,
Every
cough.
last one. Alright. So we're almost done. Okay. Alright.
It's more?
No, it's less.
Nice one.
Scooby get dead scared.
Alright, so let's finish up. So here we say, how far did the car travel for the entire journey? How far did the car travel for the entire journey? Think about that. How far did the car travel for the entire journey? Anyone?
140 kilometers.
70 km.
I heard someone whisper it, but they
140 kilometers.
140 kilometers. I like that.
I thought I was wrong, so I whispered.
Because to get to Elan, they took what? 70.
Mm.
And then they rest. And then to go back, it's another 70. So the distance that they traveled for the entire journey is 140. 70 meters to get there. Right? 70 kilometers rather to get there. Plus 70 kilometers on the return trip. That's going to be equal to what?
140.
140. Alright, calculate the average speed for the entire journey. Do not include the stops. So the average speed
Distance divided by time.
distance divided by time. Very good, Kennedy. See why we
Yeah,
needed
I've been studying it, you see?
you see why we needed you inside class? Average speed is going to be distance over time. So the distance is 140 kilometers. over time, which is 3 hours, 3.5 hours, right? So 3.5 hours. You see that? Because it was 3 hours and 30 minutes. So that's 3.5 hours. So what is 1
Yes, sir.
divided by 3.5 hours?
40.
40, exactly 40. So 40 kilometers, 40 kilometers per hour. So the average speed of this journey is going to be 40 kilometers per hour. Remember, speed equals distance over time. Any questions for me?
No, sir.
No, okay. All right. Give answer correct to the nearest whole number. Yeah. I don't know why they said that, but it's already 40, so I don't see why they say that. Okay. So is that it? Yeah, that's it. That's it for that. So pretty familiar, unfamiliar, easy, hard, difficult. How was it?
Easy. Easy.
Easy. All right. Nice. Okay, so I wonder if we have time for this one.
Yeah, next one. It's already time for language.
It's already time.
It's 8 o'clock.
Has already time for
And
language.
yeah, 5 minutes, you know.
All right. We can start it and we can leave the rest for
Hmm.
next time. Mm-hmm. Probably just gonna go to language 8.
I, I mean,
No. Okay, good.
Could you go back for me, please? Thank you.
No problem.
I finished.
Okay, no problem.
I'm gonna write the question.
Okay, so Maxine earns $12 per hour. She works a basic 40-hour week. Overtime is paid at double time. Calculate her basic weekly pay. Calculate her basic weekly pay. So our basic weekly
40 times 12?
yes, 40 times 12. So our
Yay, Kennedy.
so basically weekly pay is gonna be
I
equal to
still struggle with this one.
$12. multiplied by, where's my multiplication sign? It's going to be equal to $12 multiplied by 40. It's going to be equal to what?
$480.
$480. That's a basic weekly pay. Okay, so we know that in 1 hour she get $12. The next hour times 2, the next hour times 3, next hour times 4, and for 40 hours it's gonna be $480. Just multiply those two. Next up, we have how much she's paid for 1 hour over time. How much she's paid for 1 hour over time. Anyone knows?
24.
24. How did you get that?
Because overtime is paid in dollars.
Good. And so what do you do?
Multiply
Multiply what?
12 times 2.
12 times 2. Very good. So 1 hour over time. We know it's gonna be equal to her hourly rate times 2. Because they say double time. Now if they did say time and a half, what do we multiply it by?
1.5.
1.5. If they did say time and a quarter, what do we multiply it by?
1.25.
1.25. But they said the time, they said double time, so we have to multiply it by 2. So that's 12 times 2. It's gonna be equal to $24. Basic enough?
Yep.
So let me give you all the opportunity to write this down, and then we could go to English. Then
Why is Cooper so excited for English?
For real?
I'm not that excited for English.
I no, I feel like she's just ready to come with this class.
exactly,
That's all.
just ready to come with a math. You have nothing to do with English.
It's not that. I just didn't win the discussion.
Okay.
But I had to do it anyway.
Yeah. Okay, so overtime is gonna be 12 times 2, and basic hourly rate is going to be 480. So basic weekly pay is going to be $480. Okay.
I used to hate this topic.
Yeah, but hopefully it's easy to do now.
Before, yeah, way easier now.
Okay, that's good. All right, send in the math notes for me, please. Send in the math notes. Send in the math notes for me.
Sent.
Yes, I see it, Mr. Cooper. Okay, so let's dive into our English, right? These stories be interesting. These be very, very interesting. Anyone can remember what the last one was about?
About the train with
The
bad.
train have bad quality, and then Mr. Harvey,
Mm-hmm.
he created a restaurant, and he allowed women to work in there,
Mm-hmm.
and
Yes.
I'm like
Uh-huh. What was the name of the girls?
the Harvey girls,
A hobby gal? No.
No, not
the Harvey girls.
Harvey girls, right? Very good. And they did their work professionally, and they were paid how much a month?
Whew,
Anyone can remember?
1750.
1750 a month, right? And according to the times, to their times, that was good standard pay or bad standard pay?
but,
Standard.
Good standard pay.
but
Um, so how was Harvey's food different, and how was his hospitality different than the train?
better quality.
Better quality, yeah. Okay. So that was that one. That was that all about. Where was the location of, or where was the setting of the story? The setting of the story was what? Anyone can remember?
Um,
Was it in Europe? Was it in Russia? Antarctica? There was
America.
America.
a specific place in America, though.
Chicago.
Mm, the American West, South, East,
West.
West. Good.
The West.
Yeah, boy.
It was right there, America.
The American West. Good. And what's another thing? What was the time period of this? Was it the 1500s, the 1600s, the 1800s, the 2000s?
The 1800s?
The 1800s. Wow, you
Yeah.
very keen on numbers, Kennedy.
18.
Get it from the family.
Oh boy.
1800s. Okay, good. All right, so that was that question. Sorry, not that question, but that was that story. Ah,
That's the only one I actually remember.
now we are on the next story. And this one is, how do you like those apples? How do you like those apples? Alright, so that'll be interesting to see what this one is about. Anyone have any idea? Like, you want to give a guess before you start reading?
Probably apples and how they taste and something like that.
Apples and how they taste. Anyone else?
Uh,
How do you like
what a
those
taste. Things and the apples or the something.
They drop the apples?
They drop the apples? No.
The chemicals and then the things inside apples. Oh, how they taste.
Names, okay.
We give apples to the children and they fall asleep.
You know, they say teachers like apples. In every teacher billboard, you see an apple on their desk.
But do y'all really like the apples?
I mean, I have no choice. I am a vegan, so. But typically on the desk of a teacher, you don't see apples. You see chicken and fries and
Swear.
You did not lie.
you know, you see that stuff. You don't see no apple. But that's what's supposed to be on our desk. Because apples is brain food, right? Brain food. I like this journal Oh, Nancy. All right. So let's get to reading. Who's gonna be my reader for today? I need a reader.
Me.
I want to read again.
Oh,
Yeah, Lionel. Lionel, I'm gonna let you read, Lionel.
yeah.
Hmm. So you can start. You're gonna start from 29. I'm gonna let you read a lot because I don't want it to be too hard for you because I know these words interesting.
That's the point of reading. And you're gonna help us let the word out, I guess.
Yeah, but I also want
Yeah,
them. I also want them to understand too. So
yeah, we understand the story.
so yeah. So let's do this. How do you like those apples? Let's see how this is all about. Okay, so how do you like those apples? Ah,
Why you keep saying like
That sound just
why you keep saying
it has a nice ring to it anyway.
Does your
Sit
actor do it
in
too?
the British tone.
Oh, anyway, how do you like those apples? Marketed as Smart Fresh, the chemical 1-CP, that's 1-methylcyclopropene, has been used by fruit growers since 2002 in the United States and elsewhere to preserve the crispiness and lengthen the storage life of apples and other fruit, which often must travel long distances before eaten by consumers. 1-MCP lengthens storage life by 3 to 4 times when applied to apples. This extended life allows producers to sell their apples in the off-season, months after the apples have been harvested, and at a cost of about 1 cent per pound of apples. 1-MCP is highly cost-effective treatment. However, 1-MCP is not a panacea for fruit producers or sellers. There are problems and limitations associated with its use. 1-MCP works by limiting a fruit production of ethylene. It is a chemical that causes fruit to ripen and eventually rot. 1-MCP keeps apples tight and crisp for months. It also limits their scent production. This may not be much of a problem with certain kinds of apples that are not naturally very fragrant, such as Granny Smith, but for apples that are prized for their fruity fragrance, such as Macintosh, this can be a problem with consumers that will reject apples lacking the expected aroma. But some fruits do not respond as well to 1-MCP as others did, and some even respond adversely. Furthermore, some fruits, particularly those that naturally produce a large amount of ethylene, do not respond well to 1-MCP treatment. Now you, Lionel.
You mean me?
Yeah, start from take.
Okay. Take barley, pears for instance. Unless they are treated, oh my, hold on. Okay, I'm back. Take barley, pears, 29 pears, for instance. Unless they are treated with exactly the right amount of 1-MCP at exactly the right time, they will remain hard and green until they rot. And consumers who experience this will be unlikely to purchase them again.
Mm, okay, that explains why those pears be so hard. Okay, so I want someone to summarize the essay for me. Give me a summary of the essay. Come on. Anyone give me a summary of the essay? What was it talking about?
Talking about these one MCPs and how to change the apples. It helps them to stay ripe and also eventually rotten them. And it was talking about how it take away the fragrance, and some apples don't have fragrance like granny some. Yeah, that's why I'm.
All right, very good, Miss Cooper. Anyone else? Summarize the essay for me. Anyone? Let's go. Don't be shy. What was this essay about? All right, let me start calling names because they don't want to talk. Abigail Rule. Abigail Rule, can you tell me what was the essay about? Abigail, are you here?
Yes, sir.
Okay, good. Were you listening to the essay?
I missed parts of it.
You missed parts of it? Okay. What parts do you remember? Hello?
Oh,
Go ahead, Miss Abigail. What parts do you remember of the essay?
I don't even remember any.
You don't remember any? Okay. Anyone else? Who else I could pick on? Destiny.
Yeah, so I have reasons to pick up me, you know.
Okay. Go ahead. Who was the essay about?
I don't know.
What you mean you don't know? Okay, who else I could pick on? Mr. Meadows. Juan Meadows. What was the essay about? No, I guess we half asleep tonight. Lionel, what's the essay about?
I thought it was like, what should I say? Something about it. Wait, you're talking about the MCP being hard and never rotten.
Okay, something like that. Something like that. Okay, so let me explain. Nancy, what was the essay about?
Um, oh, okay. Based of my understanding, based of my understanding of the paragraph, it was about switching the MP thingy to better an apple then, like to preserve its life, like its longevity or something, like the longevity, like it lasts longer.
Yes.
Yeah.
Okay, very good.
The
So,
process of that process, yeah.
yes. So, basically the idea is the following. So, um, methyl cyclopropene, the abbreviation for that is 1-MCP. That is something that they put inside the apples so that the apples would last longer on the shelves. Now, it's important that they do that because the apples is going to travel from long distances. Like, for example, us who get apples from, say, America. By the time it reached here, it gotta be still kind of fresh. And if they don't put that there, it's going to rotten quickly, right? And so it lengthens the storage life. Plus, when it's inside the shop, right? When it's inside the shop, you don't want it to rot also. Because, I mean, not every day all the apples is going to go. So some apples are going to stay, and so you still want it to be fresh. And so they put 1-methyl cyclopropene into the apples. And it has the positive benefits of it is that it lengthens the shelf life, and it's cheap, right? It lengthens the shelf life of the apples, and it's very cheap. The bad of it is that, what are the negative effects? The negative effects is that, well, because what it does is that it kind of stop ethene from being produced. And if you know something about chemistry, what happens is that ethene is the gas that ripens fruit. And so I don't know if you know, one of the quickest ways to ripen fruit is that if you have a ripened fruit, like say if you're trying to ripe dilly, if you have a ripe dilly and you put it in a brown plastic bag with unripe dilly, then it's going to cause the other unripe dillies to ripen, because that ripe dilly is producing a gas called ethene. Okay, and ethene is going to help the other fruits that are not ripe to ripen. And so with this MCP, it inhibits or it stops ethene from producing. And so that could be a good thing, and also be a bad thing. Well, the problem is that for fruits that have a fragrance, they could be a problem, because customers are like, well, I'm expecting this apple to have a fragrance or a scent to it. This one don't have no scent to it like it's used to when it's natural. So that could be a problem. But for Granny Smith apples, like the ones that we see in the store, they don't really have a fragrance, they could get away with it. So this is just basically talking about the pros and cons of 1-MCP. Why it is beneficial, why farmers use it, and what are the negative effects of using it. What are the problems and limitations with using it. So let's identify some, what I would call, vocabulary words. So this one, methyl cyclopropene.
Really?
Pretty big one, right?
In the world?
Preserve is it's a good word. Crispiness, right? Consumers. When we say consumers, what do we mean?
People who eat the apple.
People who eat the apples, yeah.
Who eat, not buy.
Yeah. What's another one? Per pound, cost effective. Cost effective. When we say cost effective, what do we mean?
It's affordable.
Affordable. I like that word. Cooper. It's affordable. Limitations. What do you mean limitations?
It's only so much.
Yeah, it's only so much it could do, right?
Yeah.
It's a limitation. What else is a good one? Fragrant. Fragrance. That's the scent, right? Aroma. What do we mean by aroma?
Scent?
Yeah, same thing as fragrance. Scent. Adversely. When we say adversely, what do we mean? Adversely. Adversely. Anyone know what adversely means?
Right back?
No. Like in a bad way. So if it responds adversely, excuse me, that means it responds in a negative way or in a bad way.
Okay.
We have what else? Treatment. Hard and green. Unlikely. Purchase again. Okay, that's good. So these are good vocabulary.
Mr. T,
Yes, ma'am.
you could go back to that long word so I could have read it. I just skipped that for you.
Methyl cyclopropene. Good. All right, so we're gonna begin answering our questions on this. This is number 23, right? That we're gonna begin.
Yes, sir.
We're gonna begin with 23. Which choice? So write down remember for English, we're gonna write down the question and the correct answer. So let's look at 23. So 23 is right here. Underlying word. 1 MCP lengthens storage life by 3 to 4 times when applied to apples. This extended life allows producers to sell their apples in the off-season, months after the apples have been harvested. Which choice most effectively combines the underlying sentence? When applied to apples, 1 MCP. Someone mic is on.
They got it off.
Okay. Is it when applied to apples, 1 MCP lengthens storage life by 3 to 4 times, allowing producers to sell their apples in the off-season, months after the apples have been harvested? Or is it producers are allowed to sell their apples months after they have been harvested in the off-season, because 1 MCP, when applied to apples, lengthens their storage life by 3 to 4 times? Is it 1 MCP lengthens storage life when applied to apples by 3 to 4 times, allowing producers to sell their apples months after the apples have been harvested in the off-season? Or is it months after apples have been harvested, producers are allowed to sell their apples in the off-season because 1 MCP lengthens storage life when applied to apples by 3 to 4 times?
C?
C, someone said C. Anyone else?
To me, I was saying the same thing.
Yeah, all of them are saying the same thing, but some of them are awkward and, have redundancy. And, the ideas don't flow properly.
So which one it is?
The correct answer is going to be A.
Oh no.
When applied to apples, 1 MCP lengthens storage life. This one flows the best. Alright, next one. 24.
Alright, the answer.
Take a picture of it because it's a long answer. I can't wait for you to write it down, but take a picture quickly. Good. Number 24. It says 1 MCP works by limiting a fruit's production of ethylene, comma. It is a chemical that causes fruit to ripen and eventually rot. So we
D?
say it again, D.
I think it's either D or B. Because B and sound good too.
So one
I think it's C.
I think it's C. So 1-MCP works by limiting a fruit's production of ethylene. That is a chemical that causes fruit to rotten and eventually rot. Or is it 1-MCP works by limiting a fruit production of ethylene? It is a chemical that causes fruit to ripen and eventually rot. Or is it 1-MCP works by limiting a fruit's production of ethylene, being a chemical that causes fruit to ripen and eventually rot.
B.
B,
I think
yeah.
it's B.
It sounds better with B.
Yeah, it sounds better.
What if we just remove the underlying word?
It sounds good both ways.
It's D. Delete the underlying portion. So it'll be read 1-MCP works by limiting a fruit's production of ethylene, a chemical that causes fruit to ripen and eventually rot.
Simplicity, why not B?
Why not B?
Mm-hmm.
Here we have to choose the best answer. So
They both sound good.
the best answer would be D. Alright, number 25. While 1-MCP keeps apples tight and crispy for months, it also limits their scent production. So should we say, yeah, why it say tight?
Firm.
What do you think it is?
B.
Yeah, B. It's
B.
firm. They're not tight.
Why tight though?
I'm saying tight. It's crazy. Firm is better.
I guess they did that for the question.
Yeah. Alright, number 26.
Tight. Oh,
Yeah.
it's weird. Very butty.
Yeah. How I would use tight to describe an apple, right?
Like,
This is crazy. Okay, so number 26. While 1-MCP keeps apples tight and crisp for months, it also limits their scent production. Is that the there that we need? Is it limits its scent production? Its scent production or no change?
C.
See?
Yes.
No change. We don't need to change it. They use the correct there. Alright. Number 27. Uh Number 20. What number are we on? 20 what?
7.
27?
27.
Okay, good. So number 27 says, number 27 says, this can be a problem with consumers that will reject this can be a problem with consumers that will reject apples lacking the expected aroma.
Yeah, I see the options.
So the options is no change, they, which, who.
C.
See? This is number 27.
C.
See? This is 27, right?
Yes, sir.
So, but this can be a problem for consumers, who will reject? We're talking about consumers, you know. This will
I
be
feel like it's B.
it's D. Because this can be a problem with consumers who will reject apples lacking the expected aroma. Okay? I think that one is straightforward. Who will reject apples lacking their expected aroma? Okay, perfect. Now we are on number 28. Number 28. Number 28, here we have but some fruits do not respond as well to one MCP as others did, and some even respond adversely. And so, but some fruits do not respond as well to one MCP as others did, and some even respond adversely. So number 28, is it going to be, sorry, let me let you all see that. But some fruits do not respond as well to as others do, as well as others have, or as well as others will.
B.
Yeah, B.
B.
Some fruits do not respond as well as others do. Okay. All right. Question number 29. Question number 29. It says, take Bartlett pairs for instance. Unless they are treated with exactly the right amount. So I take Bartlett pairs for instance. Unless they are treated with exactly the right amount of 1 MCP, exactly the right time, they will remain hard and green. So
C.
C, you think C? Take Bartlett. So should we put the comma here? Take Bartlett pairs. Should we say take Bartlett pairs, comma, or should the comma come at the end? Should we have period, then for instance? What should it be?
I go with D.
If you go with D, notice the problem. It's saying take Bartlett pairs, period. Is that a sentence?
No, sir.
No, not a sentence. So
C.
can't be that.
Why makes sense?
C.
I think B.
It is B.
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 Her.
Okay, and then finally number 30. Finally number 30. They will remain hard and green until they rot, and consumers who experience this will be unlikely to purchase them again. Should it be, to make this paragraph most logical, sentence 4 should be replaced with where it is now, after sentence 1, after sentence 2, or after sentence 5. They're trying to say, to make this paragraph most logical, sentence 4 should be replaced with where it is now, after sentence 1, after sentence 2, after sentence 3. What paragraph they talk about? Furthermore, 1, 2, 3, 4, 5, 6. So when it is sentence 4 by sentence 4. This is sentence 4. Wait, they didn't number the rest, right? They just number that. So I see they did. So sentence 4. This is sentence 4, right?
Yes, sir.
But some fruits do not respond well as others did. Some even respond adversely, right? So with this one, we want to, they say, should we move it? So they're saying, should we move it should we leave it where it is? Should we place it after sentence 1, after sentence 2, or after sentence 5? So let's look at sentence 4. So sentence 4 begins with the word what?
But.
But. So sentence 4 begins with the word but, indicating what? A contrast with the
Between something.
Yeah, with the previous idea.
With the previous sentence or phrase.
And goes on to
So I got it.
goes on to mention that one MCP can have negative effects. Sentence 1 continues the discussion of the benefits of one MCP, and sentence 2 names the adverse effects of the limiting scent production. So the most logical spot for sentence 4 is between these sentences. Because look, it's best that we put sentence 4 in between here, because sentence 1 starts off by talking about sentence 1 starts off talking about it says one MCP works by limiting food production of ethylene, a chemical that causes fruit to ripen. So it's telling us what MCP does, and it tells us that, hey, it stops the food from ripening. By the time we get to sentence 2, it says, while MCP keeps apples crisp and ripe for months, it also limits their scent production. So this one talks about the negative effects. So the number one, sentence 1 talks about the benefits, but then we're saying, but some fruits do not respond well. So after talking about the benefits, then we could say, okay, but some fruits don't respond well to it though. You see what I'm saying? So it's best to put sentence 4 between sentence 1 and sentence 2. Because sentence 1 still talking about its benefits, and then it's still talking about how good it is, la la la. But then we could say right there in the middle that, hey, but even though it has all them benefits, but some fruits don't respond well to it. Okay? And so the correct answer there is definitely going to be B, after sentence 1. Okay, number 31. What? We still have more to read.
What was number 30 again, Mr. T?
I didn't even realize that.
After sentence 1.
Oh, we still have way more to read.
You see, you should have checked.
I should have.
And I can read, right after him, I can read.
Okay. Finally, researchers have found that one MCP actually increases susceptibility to some pathologies in certain apple varieties. For example, Empire apples are prone to a condition that causes the flesh of the apple to turn brown. Traditionally, apple producers have dealt with this problem by leaving the apples in the open air for 3 weeks before storing them in a controlled atmosphere. with tightly regulated temperature, humidity, and carbon dioxide levels. As the graph shows, the flesh of untreated Empire apples that are stored in open air undergoes roughly 5% less browning than the flesh of untreated Empire apples that are immediately put into storage in a controlled environment. However, when Empire apples are treated with 1 MCP, their flesh turns brown when the apples are first stored in the open air, though not under other controlled conditions. Although researchers continue to search for the right combination of factors that will keep fruits fresh and attractive, the problem may be consumers are overly concerned with superficial qualities rather than the actual freshness of the fruit. Okay, so we still have a lot more to go. So here, let's read this. This is the result of this is
I
the
thought
result.
this was early.
Say it again.
I thought this was an early night again.
Yeah, me too. But we still have more. So this is the result of treatment to control browning of Empire apples. So this is where it's untreated, and this is when we have 1 MCP. So if we have so this one represents our untreated apples, right? And it tells us how much percentage of browning that they have. So apples placed immediately in a controlled atmosphere. So when we take the apples, they are untreated with MC. They are untreated with what they try treated with. Just found that
One.
as the graph shows, the flesh of untreated Empire apples that are first stored in open air undergoes roughly 5% less browning than the flesh of untreated Empire apples that are immediately put in the storage in a controlled environment. However, when Empire apples are treated with 1 NCP, their flesh turns brown when the apples are first stored in the open air, though not under controlled conditions. So what are they trying to say here? Here we have untreated apples that are immediately placed in a controlled atmosphere, and their percentage of browning is really high. We have 1 NCP apples that are immediately placed in a controlled atmosphere. Their percentage of browning is high, but not too high. But here we have untreated apples that are placed in a controlled atmosphere after 3 weeks in the open air. And their percentage of browning is very low. But then we have 1 MCP apples, and we place them in a controlled atmosphere after 3 weeks in the open air, and their browning does increase. So let's see. So number 32, I think. 31 or 30. 31 or 30. Okay, 31. It says which choice offers an accurate interpretation of the data in the graph. No change, roughly more browning than, twice as much browning as, substantially less browning than. So this says that as the graph shows, the flesh of Empire apples that are first stored in open air undergoes, so the flesh of what? Empire apples that are first stored in the open air undergoes roughly 5%, they say roughly 5% less browning. So is that the correct answer though? If we look, is it true that the flesh of untreated Empire apples that are first stored in open air undergoes roughly 5% less browning than the flesh of untreated Empire apples that are immediately put into storage? Look at the graph. The flesh of those untreated ones that are put into storage is this. That's about 50% browning. But when they are not placed in a controlled environment, notice that the percentage of browning decreases.
Decrease.
It decreased substantially. It didn't decrease no by roughly 5%. That thing decreased substantially. You see what I'm saying? Like that's a big drop. You know what I'm saying?
Yeah.
That's a big drop. That I know 5% drop. So what I mean is this is still is 50%. Now it's gone all the way down to like, 8%.
Yeah.
That's a big drop, right? And so
Yes, sir.
the correct answer should be substantially less browning. Okay, so they undergo substantially less browning. Number 32. Which choice offers an accurate interpretation of the data in the graph? Is it A, no change? Is it, however, when Empire apples are treated with 1 MCP, their flesh turns brown when the apples are first stored in the open air, though not under other conditions? If we look carefully at the graph, when we take apples that are treated with MCP and we put them inside a controlled environment, they have about 45% browning. But when we take them and we put them in open air,
So let's see.
yeah,
What the answer was for number 31?
it was D.
Alright.
Yeah, so here we're talking about the apples that were given MCP and placed immediately in a controlled atmosphere. They have about 45%
What is
browning, right? For 45%. But when we take them and we put them immediately in a control, if we place them in a controlled atmosphere after 3 weeks in the open air, the browning is more.
like 54?
Like for 52 thereabout, right? So the browning is more. So if we take the apples that have 1 MCP and we put them immediately in the controlled atmosphere, the browning is 45. If we take them and we say keep them in open air for 3 weeks and then put them in the controlled environment, the browning is more. So here it says which choice offers a accurate interpretation. Is it that, hey, they are roughly half of their flesh turns brown, regardless of whether the apples are first stored in the open air? Their flesh turns brown when they are put directly in a controlled atmosphere, but when they are first stored, but not when they are first stored in open air. Their flesh turns brown when they are first stored in open air, though not as quickly as apple flesh in an untreated group does. So this is number 32. Is it roughly half of their flesh turns brown regardless of whether apples are first stored in open air? It's definitely B, because look at it. It says roughly half of their flesh turns brown regardless of whether the apples are first stored in open air. And if we look carefully, percentage of flesh browning, we found that 45% of the flesh is browning and 52% of the flesh is browning, whether you place it in the control atmosphere or not. All two of them is close to 50. You see what I'm saying? So still roughly half of their flesh turn browns. Doesn't matter whether you put them first in the open air or first in the controlled environment. Doesn't matter. Still about roughly half of their flesh turns brown. So the correct answer is B. And then the third one the third and final one, is that the writer wants the conclusion to convey how the shortcomings of one MCP presented in the passage affect the actions of the people in the fruit industry. Which choice best accomplishes this goal? The writer wants a conclusion that conveys how the shortcomings of one MCP presented in the passage affect the actions of the people in the fruit industry. Which choice accomplishes this goal? So is it no change?
I think D. I don't know.
Is it many of the improvements to fruit quality they have discovered so far have required trade-offs in other properties of the fruit? Is it for now many fruit sellers must weigh the relative values of aroma, color, and freshness when deciding whether to use one MCP?
D.
Or is it must be acknowledged that one MCP, despite some inadequacies, has enabled the fruit industry to ship and store fruit in ways that were never possible before?
D.
Say it again.
D.
The correct answer is C. Reason being is that it says, for now, fruit sellers must weigh the relative values. So they're saying that, hey, the fruit sellers must count the costs. They must think about pros and cons, right? And that's what they wanted us to say. It's the writer wants a conclusion that conveys how the shortcomings of one MCP presented in the passage affect the actions of people in the fruit industry. So how much people in the fruit industry? Yeah. So how much
I thought you were
yeah, so how much people in the fruit industry react to the shortcomings of one MCP? Well, they have to weigh the pros and cons. Okay? And so that's that. And so the correct answer is definitely gonna be C. Okay? Any questions for me?
No, sir.
Questions?
No stop.
No? Okay. So we're gonna end there. That is day 3, week 6. And hopefully you learned something tonight. And I'll see you on tomorrow, God's Spell Life. That's gonna be our last installation. That's
Sadly.
sadly. That's tomorrow at 6 p.m. So have a wonderful night and see you tomorrow, God's Spell Life.
Bye.
Pretty.
Yes, ma'am.
Remember the video so you're supposed to send me? You won't send it yet.
I
I'm
haven't forgot.
waiting.
I haven't forgot.
Okay.
Okay, no problem.
Bye, Mr. Petite.
Yeah, take. You know what? Ask Miss. You know Miss Cooper number? And I don't give a phone. All right, no
I
problem.
do, but I just use it on weekends.
Oh, ask her to send. Ask her to send you a tea. Does she have it?
I don't have Miss Cooper number.
You know Miss Cooper number? Okay, then I have to send it then. All right, then no problem.
Bye, Mr.
Good night.
Petite.
Yeah, take care. All right. Let me end this recording.